This solar heater is about 10 times cheaper than these traditional solar collectors, and it is several dozen times cheaper than its relatives. These expensive concentrators should constantly turn their mirrors, and now I am starting to show how they do it during a day, and the time is shown here. We know that these expensive solar concentrators are the basis of large solar power plants, and now the value of all these plants is approximately $40 billion. For example, the construction cost of this plant is $2 billion, and this is its satellite photo. We can see that the rows of its concentrators are located along the north-south line, and these photos of other plants say that they also have a similar north-south location. But now I will show a satellite photo of this solar station, and we see that the rows of my solar heaters are located along the west-east line, and this is their main difference from those expensive solar concentrators. This location along the west-east line allows the rejection of those mirror turns from morning to evening, and now I will show photos of one day but at different points in time, which is shown here. We see that this part of solar radiation from my mirrors accurately hits the observer during the whole day. Here we can see that the mirrors are very mobile, and these shadows show us that the sun is moving. But this day was near the spring solar equinox, and this spot will just as accurately hit the observer also near autumnal equinox in September. However, the closer to the solstices, the spot hits the observer less accurately, and now we see the movement of the spot near the summer solstice in June. Now I will show how the spot moves near the winter solstice in December. Interestingly, in winter the spot comes from above, and in summer it came from below. And the spot goes up in winter, but in summer it went down. We can see that our cheap solar heater has a high absorber. At the same time, this expensive solar concentrator has a thin absorber, and this concentrator is expensive due to the fact that it should be very precise, because its spot must be a very thin line. But our equipment should not be precise, and therefore it has the right to be manufactured from cheap raw materials using primitive technologies which do not require large investments. So, our solar heater does not have a mechanism for the constant turning of its mirrors, but we must do this operation. This is a change in vertical inclination of the mirrors, and we see that it is a simple and quick operation. I have to do this about once a week, but we understand that this operation can be done several times less frequently if the height of this absorber is greater. I am researching not only this solar technology, but also its relatives, and this is one of them. We see that this receiver is fixed on the ground, and this technical solution gives us several advantages compared to this fixation of this receiver to the mirrors. This is another example where this receiver takes solar radiation not only from the mirrors but also directly from the sun. In addition, I am researching several more relatives of this large family of solar heaters which should be located along the west-east line. That is why they do not require turning their mirrors from morning to evening, and I will describe these relatives in my future videos. So, the topic of this video is only this system where the receiver is fixed on the mirrors, and I suggest we think about where this system can be used. We know that these expensive solar concentrators heat special oil up to 400 degrees Celsius, and this heat is used to generate steam, which rotates a turbine and electric generator. But some part of the heat goes into these heat storages, and it is used to generate electricity in the evening and at night. Obviously, this is a big advantage over the solar panels, which produce electricity only during sunny hours. Unfortunately, this solar heater of my solar station is not intended to heat more than 100 degrees Celsius. But I think that these changes in its design can give us a solar heater which is capable of producing heat at a temperature of 150 or 200 degrees Celsius with high efficiency. However, most likely those other relatives of this solar heater can provide cheaper electricity, especially if they are able to produce heat with a temperature of more than 200 degrees Celsius. But this type of solar heaters may be of interest to replace similar solar collectors, which produce heat for industrial processes of food, textile and other types of